All right, so let's start unit 2. So we're going to be talking about logs. If you guys haven't dealt with logs, well, you probably lived a happy life if you haven't dealt with logs yet. Um, but the main idea of logs is that they're the opposite of exponents, and they're a little weird to enter into the calculator. So this unit's going to talk about how we can enter that into the calculator and a bunch of other things. So as always, guys, make sure you're paying attention to the objectives. So in this case, we're going to learn how to examine a logarithmic function. All right. And the main idea of logs is this idea, like I said, it's unit 2 is locked. Let me unlock that for you then. Does anybody else have unit 2 locked? Does anybody you have unit 2 locked as well? Okay. Anybody else?
Sorry, what did you
do you
So high.
do you have unit do you have unit 2 locked?
Oh, let me.
Oh, cracky.
I am so glad that this doesn't come out on the YouTube channel when you guys are talking about.
Yeah, no.
No, you don't have it locked, or no, you have it. What?
I hope that goes on the. I hope that's on the YouTube video. Oh,
I I am I unplugged my headphones. I didn't hear anything that happened.
No wonder he's stored on my.
Nick, did you say you have it locked also?
no, no, no. Mine is unlocked. I'm sure.
Okay, cool. Lily, is yours unlocked?
Yeah, mine's unlocked.
Okay, cool. All right. Now that we got that out of the way, let's get back to the logs. All right. So if we look at logs normally, in this case, they're looking at this b function. What's happening here is we have no pencil on. There we go. We have this function right here where we plug this in for our x and we get that out. But what if we had our y? So remember, we've just went through inverses. So if we want to go from y to x, there's no real way to do that right now, right? Like, how do we do this? So we're going to learn about logs and how we can find the inverse of an exponential function. So let me move on. I need to move this so it's not in the way. There. So when we're doing this cell division problem, and they want us to figure this out, like, oh, what happens after this amount of hours, how many cells we have. This part's easy because this part's just exponents, right? This is just a matter of doing 2 to the, that's a 2. There we go. 2 to the 1 equals 2. And that's how we get this. 2 to the 2, that's going to be our 4. 2 to the 3, that's going to be our 8. So this part's going to be really easy for you guys to fill out. In fact, there's the answers right there if you guys need them. But I don't know if I've mentioned it in this class before. I've mentioned it in other class. If you guys need like a scientific calculator at home, you can always just type in calculator into Google. In fact, if you're on the Chrome browser, you can just literally type it into your Chrome browser and it'll give you this scientific calculator right here. So you can always do this. 2, let's say we wanted to go to the fourth power, use this little XY button to the power of 4, and that's how we get our 16. So did I open up? I opened it up twice. There we go. So that's how we get the 16 right here. And if we did it again, we would get the 36. It keeps doubling basically. So when we went over exponents, that's what we learned about. So this part should be very easy for you guys because we literally just did it in the last lesson. But now let's say we have the number of cells and we want to go the other way around. Well, when we're switching our x's and y's, we kind of get stuck on this step right here. That's where logs come into place. So when we're doing logs, the opposite, the inverse of 2 to the x, y equals 2 to the x, if we wrote it as an inverse, it would be x equals log base 2 of y. Does that make sense? Yes, no, maybe?
Yes. Yes, Commander.
Cool. So if I were to color code this, the way I would do it is like, let's say I put y in yellow equals our base is 2 and our exponent, let's make it blue. If I wrote the inverse, it would end up being y equals log of base 2. And then what did I write my y in? My y was yellow. X. Oh, so that's how we would do this. So basically, this base here is the same base as right here. That's the main idea on how to do logs. So that's going to be the entire basis on how we continue doing this. So give me a second real quick. And again, guys, focus more on taking your notes than on trying to complete what I'm doing here because since we have so much to cover, like I'm not going to do every part of the activity. You guys should be able to do that on your own by now. So what's happening here is instead of going like giving us the x and plugging it in, what we're doing here is we're kind of saying like when we do log to the 2 of 1024, what we're really asking is 2 to what power gives us 102.4. That's the easiest way to remember it. If you guys understand this idea of y equals b to the x is the same thing as saying x equals log base of y, this is going to make it so much easier for you guys to understand how to do the rest of it. So this is the whole basis of what logs are. All right, so if we're doing cell division here, so now we're going to do the cell division problem that they're giving us. So using the scenario described in the lesson, so that one about logs, how many cells would there be after one complete day? So again, if this is y equals 2 to the x, after one day, we should have 2 cells. Oh wait, is there a different problem? There is a different problem here. Hold on. Which activity are they talking about? Read the direction for each. Okay. Using the scenario described in the lesson. Are they talking about? Oh, they're talking about this scenario. I'm sorry. Wait, 2 to the y, blah, blah, blah. You would read this equation as log base this, exponent that. So after 10 days, there would be that many cells. Well, that makes sense. But which problem are they talking about? They said after one day, right? Am I reading something wrong, guys?
Perhaps. You are. Maybe you aren't. Who knows? We're not telling you. Telling yourself on your own. 'Cause you know you can do it.
I know I can do it, but if you guys would help me out, it would be faster. How many cells will there be after one day? This should be 2, using the scenario described in the lesson below. Oh, every hour. I'm sorry. 1 cell. I didn't read the directions. I'm sorry. Always read your directions, guys. So 1 cell splits every hour. So in other words, it's 1 cell every hour. So if we're doing this, we're doing 2 to the 24 power. So that's too much for me to do. So what I'm going to do is going to do 2 up 24, and my answer ends up being this. I don't like how calculators don't have commas. Does that make sense?
Yeah.
So basically, if the coronavirus duplicates twice every hour, that's how many.
Much faster.
Would that make sense, guys? So that's how they're doing it. It's every hour. There's 24 hours in a day. So our answer is going to be 16,777,216. I think after a while you kind of stop caring about the smaller numbers and you're just like, all I heard was 16 million. All right. So now it's saying approximately how long will there be that many cells? So this one's a little different. They're giving us this 5,000 and they're saying how many hours? How long will it take for this to happen? Or in other words, they're saying log base 2 of 5,000 equals what? So I'm going to show you guys how to do this. Does this have a log? Yes, this does have a log. So if you notice on this though, guys, I don't think they talk about it yet, but I'm going to explain it now just so you guys are able to do these problems with the test. This is log with no thing at the bottom, right? All we've known is about log, and then we have a base here and a number here, right? Well, if it just says log, it's talking about log base 10. Now, the problem is this calculator doesn't let us put it. So what we have to do here is we're going to have to do log of our big number first divided by log of the base. And let me kind of bring this out. So this is known as our base, and this right here is known as what's called our argument. So if we want to use this scientific calculator, what we're going to have to do is we're going to do log base 10 of our argument. So let me erase this now that you guys know that what an argument is. So log base 10 of our argument divided by log base 10 of our base. Does that make sense? So in other words, we're going to do log base 10 of 5,000. Oh, my numlock isn't on. 5,000, close my parentheses, divide this by log, log, and our base was 2. So our argument was 5,000 and our base was 2. And when we hit enter, we get about 12.3 hours. So I'm saying it's about 12.3 hours. Let's see what Edmentum says. Momentum says it's about 13. So what they were doing is they were doing it like this. I wouldn't recommend doing this. They're like, well, we know that it's bigger than to the power of 10. So they just kept going and going and going. Now that you guys know the base trick, you can just plug into your calculator log of your argument divided by log of your base. So you're going to get more than 12 hours. So you can literally just write more than 12 and less than 13 if you want. If you want to be more accurate, use that log of the argument divided by log of the base trick. And then rate how you guys did. Everything making sense, guys? Okay. All right. So now we're going to lose logarithmic function is defined as the inverse of an exponential. So we've already done exponentials. We've already done inverses. So that's how come we reviewed exponentials, even if you guys might have been a little familiar with exponentials. It's so we could understand what a log is. And then it kind of goes over this. I remember this thing where I did like 20 minutes of work just to type in like a 2-second answer. That was annoying. The domain of f is this. So this is just the inverse notation is what they're basically saying. And they're saying if it's the domain of f, then it's the range of this. That just means your x's and y's are swapped. So they're just basically going over inverse functions again. They're being nice to you guys. So now they're going to ask us about graphing these. So the first thing we're going to do is we're going to do log of 2, log of that, right? So if we wanted to do this, I don't know why they're asking you this without teaching you how to put it into a calculator first. But now that you guys know, we're going to do log of 1 divided by log of 2 because 2 is our base. So we're going to go, let me delete this. If we want to do log base 2 of 1, that translates into log of 1 divided by log of 2. So let's type this in to see what we get. So clear this out. Log of 1 divided by an argument of log of 2. And we get 0. What this means is 2 to the 0 power equals 1. So here we're going to get 0. What do you guys think the answer is going to be to this? Log base 2 of 2. Or in other words, 2, let me write this in yellow. 2 to what power? I'm going to write this in blue. Gives us 2. What do you guys think the answer is? I hope all you guys know what this answer is. All right, we're.
Oh no.
Yes, Garrett, that's correct. It is 1.
Yes.
For all
Such a genius.
for all of you watching at home, Garrett answered 1 and not a sarcastic answer.
Alright, I'll be right back. I'm gonna go check around the kitchen. Scavenge it up the raccoon.
All right. So the next question. So this was 1. So they're doing this pretty easy for us because then the next question is log of what power? So what power of 2 gives us 4? That's just going to be 2. Well, guess what? 2 times 4 is 8. So this is 3. Well, guess what? 2 times 8 is 16. So this is just 4. Does that make sense?
Yeah.
Cool. All right, moving on down. So then they want us to graph this. So I don't know why I erased my numbers because I need those numbers. 1, 2, 3, and 4. All right. So here, if we're going to graph this, we're going to go 0 and 1. So you can use the tools they give you here. What's this? A curved line? Well, that's interesting. Anyways, I'm just going to use the tools they give me here, but because I'm not a student, it doesn't let me, so I'm just using this. So I'm just going to go to 1 for my x and 0 for my y. 1 for my x, 0 for my y. And then I'm going to go 4 for my x, 1. And then I'm going to go, oh, I'm sorry, 2, 2 and 1, 4 and 2. That was my bad, guys. I'm sorry. I'm trying to.
Okay, listen. All right, listen. We're going to let you go.
I'm trying to do this based off memory. And then 8 is 3, so that's going to be right here in the middle. And 16 is 4. So what's happening here, if I were to graph this, it would kind of look like this weird little curve. Right here. Do as the best you can. I imagine this tool is really helpful for doing that, but that's basically what it looks like. It looks like this kind of like starts getting close to 0 and goes over. And then you can see it here. Oh, they literally only want you to put the dots. That's
Are you
easy.
tired?
Yeah, I am. I'm sorry.
It's okay. You can go to sleep. Just end class now.
Wow.
Save
that,
yourself some time. Go to
that,
sleep. Take a nap.
that's not how this works.
Not.
So here all we're doing is they just want the dots. Easy peasy. So now they're going to make it even. Wow. I don't like Adventum sometimes. They're like, fill in these blanks. Oh, by the way, later on, we're going to assume you filled them out correctly. So the answers are right here. So this is saying 2 to what power gives us 1/2? Well, this is just saying put 2 to the bottom. So this is -1. And 2 to what power gives us 1 to the 4? Well, this is, we put 2 to the bottom and square it, so this is -2. It's the same thing as saying this. So we're going to do the same thing with the 8. The 8 is the same thing as saying 2 to the third, but since it's at the bottom, this is 2 to the -3. So this is -3, -2, and this one's -1. Does that make sense? Cool. And then if we look at this, they even already graph it for you in the next one. So literally the answer to this, if you guys get this wrong when you guys are doing your tutorial, I'm going to have a talking with you. The answer to part B is literally on part B of, or part A of question 2. Wow. Anyways, if we were to graph this, what happens is, since our y's are negative and we're dealing with fractions, if I were to plug these in, I'm dealing with these little fractions right here. So it's getting really close to 0, but it never touches 0. Does that make sense?
Yes.
And then this one, question 3, now we're doing log base 2. So 0 there. So this one, they want us to graph this 2 to the x power. And if you guys ever need help graphing, what you can do is just go to Desmos to help you figure that out. For those of you who took Algebra 2 with Miss Anoush, you guys probably use Desmos a lot.
Oh,
So we're going to do 2, use our little keyboard to do the little power symbol to x, and then we see that. Now, what it's going to say here is we should notice that if we mirror this image off this line, this y equals x line, they switch. And we learned this when we're doing exponents. An inverse is just a mirror image of the reflection over this line. So I know that sounds complicated, but basically we're going to do a y equals x line and we just fold it over and we get the inverse. That's all it means by a reflection over the line y equals x. So if we switch this one over here corresponds with this point because it's folding over, folding over, folding over. So it should be kind of a review from when you guys took geometry also, that line of reflection thing. And then just do the task. So moving on over here. So log, if we make a log a fraction, it actually flips it over. So where's my pen go?
I ate it.
Did you eat it? How did
No,
how
delicious.
how'd you manage that? I'm like 2
I
hours.
created it, I placed it in your computer, and I just let it do something. It did a mini me, which ate it.
You gave my laptop COVID.
Program.
You gave my laptop COVID.
Yes, I did. I typed in basically COVID. Yes. And instead of COVID, it's actually just eating a pen.
It eats a pen. Okay. I just realized how weird that's gonna sound when someone watches this video in the future.
Yes, yes, it is. If you don't, that's fine.
So what happens here is when you get this fraction, is it flips this image over. So that's all that's happening here. Because the reason being is, think of it this way. Remember how we said exponents as fractions? It's just a negative power. So if we have 1/2, that's technically just saying 2 to the negative 1. So we can see that here. So if you guys ever wondered why we use the negative symbol, this is why. When we're dealing with like logs and stuff, it makes it negative. So that's why we use this negative symbol. I need to drink some coffee.
Do you want? Loser.
Wow.
Ahead.
Why is this moving? Stop it. Stay. Good pen.
Good. Just download that duck virus.
All right. So now it wants us to create a graph of similar values. Let's bring Victor Cost. That'd be quite a trip. All right, so now we're gonna do create a table with the values of x, choosing a range similar to the values that you picked on that one, but with threes. Okay, so basically what they're saying is they want us to do this with the power of threes. So in other words, I'm gonna do something like, so this is 3 to x power gives me what number, right? So if I put in a, let's say 9 here, for example, the answer is going to be, wait, which way do they want us to do this? Log is this. Oh, my bad. Yeah. So if we do this, then this would be the 2. Does that make sense? Because 3 squared equals 9. So if I wanted a 3, this would just be a 1. If I wanted a 1, this would be 0. Because 3 to the 0 power equals 1. Does that make sense? So if I do 3 here, this would be 27, because 9 times 3 is 27. If I do 4, oosh, I need a calculator for this one. I need, where's my calculator? Calculator. I don't know how to spell calculator. So 2 up. Why didn't my 2 type in? 2. Okay, there we go. 2. We're doing 3. I'm so sorry, guys.
2, we're doing 3. Sorry, guys.
81. And then we're just going to keep going and going and going. So let me just get that over with. Times 3. So this is 243. This is 5. I'm going to make this easy, so I'm going to do 1 over 3, which is negative 1, and I'm going to do 1 over 9, which is negative 2. And then let's see what Edmentum wanted us to answer. Oh, they wanted something similar. Actually, did they do the exact same thing? They did the exact same thing, except they didn't go all the way to 5. All right, and then we're going to graph this. So if we're graphing a log, basically the only thing that changes is we're still going to be here at this 0, 1. And the main difference here is when our x is 3, our y value is 1. So the main thing that changes, this is pretty much the same as the log of 2x, but our difference here is this point right here. This changed because instead of it being 2 comma 1, it's 3 comma 1 now, which means this grows a lot slower than 2 to the x. And I can show you that using Desmos right now. Give me a second. So let's say we're doing logs. So I'm going to go to functions here, miscellaneous, log base 2 of x. I'm lazy, so what I'm going to do is I'm just going to copy this, paste it, but then I'm just going to change this 3 or this 2 to a 3. And you can see here, let me change the color. Oh, I can't change the color. That's not fun. So you can see here that this log base 3 grows a lot slower. It grows fast at first, but then after a while it just grows slower. And that makes sense because think of their inverses. Log base 2 grows fast, but log base 3 grows a lot faster.
It's the other way around.
What happened?
Make itself just become extinct.
Yes. So you're talking about exponential decay?
Yes, if we're the other way around.
That would be if your power was different, if you had a negative exponent. All right. So moving on. So when I graph this, you'll see it's pretty similar to our log of x. You must answer the question. I can do whatever I want. So here you'll see how it's just not growing as fast. State the domain of the function. Well, the domain is all the x values at work, right? This never touches 0. It can never get to 0. So you would say something like, I would go to my equation editor. I would say 0 is strictly less than. It is never equal to. So I want to make sure I use the strictly less than x. And then I use the and x is less than or equal to. And this goes on forever, right? It just whenever I look at the graph, this goes on forever. So I want to use the infinity symbol here. Where's infinity? Did your virus eat it?
Yes.
Does it not have the infinity symbol? Wow, this doesn't have infinity. I can't believe their equation editor doesn't have the. It has sigma, but it doesn't have infinity. I don't even understand. We're gonna use phi as the infinity symbol
Beat it.
because there's no infinity. So okay. So if we look here, oh, they just say it's greater than 0. I mean, I guess if you want to take the lazy way out. But that makes sense too. X is greater than 0. X is always greater than 0 is an easier way of saying x is 0 is less than x, and x is less than or equal to infinity. Well, I guess you can't really say equal to infinity. Another way of saying this, I guess, would be using the parentheses 0, comma, infinity. But since there's no infinity symbol, again, we're going to have to stick to x is greater than 0. Now it wants us to know what the asymptote is. So the asymptote is what line it never touches. So it's never going to touch the y-axis. So you can say y-axis, but if you want to be a little more correct, you're going to want to say x equals 0. It's a vertical line, so vertical lines are always x equals something. In this case, since it's the asymptote, it's going to be x equals 0. And you're going to want to say asymptote to specify that you're doing the asymptote. Does that make sense so far, everybody? Cool. All right. So moving on, we're going to do definition of logarithms. So we already know the definition. They're inverses, exponential form of logarithms. So that's this idea that I showed you guys over here, where it's like if y equals log base x. Another way of writing this is saying x equals b to the y. And I think I saw this in Miss Anusha's class. She had it written down somewhere where it said like y equals our, I think she did base and then it was like number. So then when you wrote the other way around, it was like y equals log your base, but instead of this being your y, this was really your number. Either way, whatever helps you guys remember it, that's great. I personally like this way because you can see that it's the inverse because the x and the y's kind of switch position. But just as long as you remember that, it's really going to help you understand your log functions. All right. So if we're saying x to the negative 3 equals that, we're really asking log to what power gives us this. So we're just rewriting this log into an exponent form. This one's asking, in other words, our base is 10. So we're looking for something with log base 10. And it's going to give us this. So we can do that. Later on, like I said, we haven't learned it yet, but log base 10 is the same thing as this log parentheses thing. ln equals 9. So ln, I don't know why they're like, oh, they don't know what log base 10 is, but they're going to know what ln is. Log base e is the same thing as natural log. Because e is the natural exponent, so log base e is the same thing as natural log. So this goes here. Oops, 9. Sorry. And then log base 5, so our base is 5. So there we go. Does that make sense, everybody?
Yeah.
Cool. Moving on. Normally I would have like finished this unit by now, but I'm like, there's a lot of slides. Let me take a look at the slides. That way I don't cram your guys' head with a bunch of stuff. This doesn't look that bad. It does get a little harder later. All right. Well, it's not difficult. I'm just saying I don't want to cram like what is that? 41 slides into Wednesday's lesson. How have I already done that? So let's try to get to like at least slide 25, it looked like, or something. So what they want us to do here is when we're doing natural log, they just want to do that parentheses thing. ln is a, so I think this has ln. Does this have ln? Yep, this has ln. So for now, using the Google calculator is just fine. If you guys need help using the graphing calculator, let me know. I can always cover that during class. But for the most part, you can always just use a Google calculator. Using the calculator in your computer, I guess could work, but I don't like how this you have to kind of do it by term. So Google, I think, has a better calculator than if you're using like a built-in calculator on your computer. I think personally. But we're not gonna go over these because this is literally just plug into your calculator, and I'm pretty sure you guys know how to use a calculator. Well, you can make an appointment, and I'll teach you, Garrett. So this, guys, when you get to this slide, I really want you guys to write these rules down. This is a big part about logs. These rules. So basically, if you're multiplying an argument, it's the same thing as doing the same log with the same base, but you're adding them individually. So in other words, let's say I had something like log base 3 of 9. This is the same thing as saying log base 3 of 3 plus log base 3 of 3. And that makes sense because 3 to the second power is the same thing 3 to the 1 plus 1. So yes, if you guys had any doubts, 1 plus 1 does equal 2. But that's basically what this is saying. Because remember, this is saying 3 to what power gives us 9? So in other words, 2. And then 3 to what power gives me 3? And that's 1. Does that make sense? All right. And then dividing by something, that's the same thing as subtracting. This is written terribly, by the way. Don't write it down like this. I just saw this. This is bad. It's supposed to be something like this. Log b m divided by n is equal to log. This part's right, but basically this part is supposed to go over here. So if you guys are writing down notes, don't write it like this. That looks terrible. Like it's written bad. That's not how you're supposed to write that log property. All right. And then there's the exponent rule. The exponent rule just says if you have an exponent here, it's the same thing as multiplying it over here. So you can put this exponent in the front. So all you have to do is figure out this log and then multiply by this exponent if you're having trouble. And we'll get into how to use it practically later. But like, let me just show you an easy one on how to do it. Let's say I had something, I'll use the log base 3 again. So let's say I had something like log base 3 of 9. Well, another way of writing 9 is writing it as 3 to the second power, right? Well, this is the same thing as saying log base 3 of 3 to the second power, right? Those are the same thing. But now what we can do is we can do 2 times log base 3 of 3. And guess what? Now you have 2 times 1 is equal to 2. So in case you guys had any doubts, 2 times 1, that equals 2. Not funny the second time around, I see?
Nope.
Oh,
Wasn't even paying attention. What?
well. So what's different, Garrett?
Nothing, man, just, struggling at home,
Okay.
trying to feed the kids, 3 lives.
What?
Hey, man, just really struggling.
Anyways.
Man, I'm telling you.
Taxes were due a month ago.
I know, that's why.
Anyways. So here's some general expressions. The one I really do want to kind of get into is this radical form right here. Another way of writing radicals is, remember, this is similar to exponents, right? So if you had square root of 3, this is the same thing as saying 3 to the 1/4 power. So that's how come we end up getting this thing right here. They're rewriting this as an exponent. So remember, radicals can be written as this. So if you have a square root of x, this is the same thing as saying x to the 1/2 power. Did they say this on the previous slide? I feel like they kind of skipped over that. Yeah, they totally just ignore that part on the radicals and they just expect you to know it over here. But that's the main idea. Another thing here, that's equal to that. They kind of go into it a little bit more here. What they're doing essentially here is if you have this expression, what you can do is you can raise this. I say raise, but I say base it. I kind of use the word base as a verb. We're going to base it to the power of 5. So we're going to do a base of 5. This cancels out. Base of 5, that cancels out. And all you're left with is this part right here. Does that make sense? Because what's the reason why this makes sense is think of it this way. Let's say we have log base 3 of 9 and this equals 2. Another way of saying this is we're asking 3 to what power gives us 2, or gives us 9, sorry, gives us 9. This says 3 to what power gives us 9, and that would be 2. But another way we can find out even faster is by going like, what if I just raise this to the 3rd power and we're just left with that 9? So in other words, 9 equals 3 to the 2nd power. So basing it gets rid of our logs. Logs are a lot harder than exponents, so that's why there's usually a way to do it from exponent. Then we're going to start talking about log base 10. Log base 10 isn't something really special. Like we've talked about, base 10s are special because they can kind of give us our placeholders, right? So if I said something like 0.23, we can literally just write that as 2.3 times 10 to the -1. This is why the power of 10 is so special and we use log base 10 a lot, is it kind of gives us our decimal placement. So we can do anything with the power of 10 to move our decimals around. That's where scientific notation comes from. Does that make sense? All right, so moving on. I don't think there's anything too much here. They're just kind of using the properties here. So they're going to cancel out this natural log and this e. So they took the natural log of both sides to kind of get this out. This, they're going to do what I call the basing. We're going to do the base of power of 3. That cancels this out, and then we just have algebra after that. Simple algebra. So that's how we can get rid of these logs to make it easier to solve. Everybody good? So now they want us to write this as a single term. So the first thing I'm going to notice is I have powers here. So I'm going to use my power rule to move any exponents to the front. So when I'm typing this out, I'm going to write this as log subscript of, what is that, 2? Log base 2, x, use the superscript button, or you can use control up. If you're using a Mac, it would be command up on your keyboard. And I'm going to use that to the power of 2. And then plus, I'm lazy, so I'm just going to copy this part. I'm going to copy that part, paste it over here. And then my argument is x plus 5. And now since I'm using addition, this can be simplified into multiplication using our multiplication rule. And if you guys are lost, basically what I'm doing is this rule over here. Oops, went too far. This rule here where it's like if we're adding it, we can multiply them together. That's all I'm doing. Going back, and it's going to get rid of everything I typed, huh? Yes, it did. X command 2 plus log argument is x plus 5. And then we're going to multiply these two together. So it's going to be log base 2. The only reason we can do this, guys, by the way, is because the bases are the same. If the bases were different, we wouldn't be able to use all of these log properties. So this becomes log x to the power, oops, I didn't mean to do that, control up, to the power of 2 times x plus 5. Does that make sense? And it's going to tell me I'm wrong because they only want this part right here. Watch. Why is it still saying it's wrong? That's what I wrote. Oh, they wanted me to distribute it. So they wanted me to distribute the x squared. Okay, that makes sense. I'll give them that. I didn't distribute. All right, guys, I'm going to try to get these done. So then you guys don't have to worry about this. You can always just watch the video later. So write this expression as a sum and difference formula. So the first thing I see here is like, this square root can be rewritten as an exponent. So I can rewrite this as ln natural log ln of, I have a fraction, so I'm going to use my fraction button, x minus 1. On the bottom, I'm going to write x, close my parentheses, and this is going to be to the power of a fraction, which is 1/2. From here, I can use my exponent rule, my power rule, to say this is 1/2. Oops. 1/2. Where is it? ln parentheses fraction x minus 1 over x. Oh, I forgot. You guys like it when I actually like write it down instead of typing it in, right? Okay.
Yeah.
So let me finish this off first. So now another way of writing this down is I'm going to use my quotient rule to make this a subtraction. So I'm going to do this as 1/2 parentheses ln of x minus 1 minus, because we're dividing, ln, because remember, all ln is log of base e. So that means that they are the same base of the log. And this is of x. And then I have to distribute this 1/2 to all of them. So this becomes 1/2 ln of x minus 1 minus 1/2 of ln of x. So that should be my answer. I'm just going to click done. It's going to tell me I'm wrong, and then click answer. And then you see that it's this. Oh, they actually, wow, they only get mad at you if you don't distribute later. I don't like Edmentum. I don't know why they want you to factor it. It's like simplify it out. It's like, why would I simplify? You guys are telling me to expand. So again, guys, if there's not that many fill in the blanks on mastery tests, luckily, but if you ever do get there and I see that you did all your work right, I will give you points for it. like for your activities and stuff like that. And are there that many more of these? I'll just finish this off, and next week we'll start with the activity. So give me a second, guys. So if I'm doing this, if I have this ln of 65 minus ln of x equals ln of 39. First, I want to make everything into two nice ln's. So since there's a negative here, this is going to be ln of 65 divided by x equals ln of 39. I need to get rid of this ln, so I'm going to raise it or base it to the power of e. That cancels this out. So now I have 65 equals x. Oh, 65 over x equals 39. I'm going to multiply both sides by 39. In other words, I'm going to cross multiply. That's an easier way of thinking about this. I'm going to multiply that. So I get 39 x equals 65. So in other words, I get 65 divided by 39 as my answer. So let's have this yell at me right now. It's going to tell me I'm wrong for whatever reason. 65 divided by 39. Oh, it actually told me I'm correct. That's the first. Remember, guys, make sure you're showing your work. And as long as you're showing your work, I'm going to give you credit. You know, if you're not showing your work, then I'm probably, even if you're right, I'm probably going to take points away because I'm like, how do I know you did this right and you didn't just Google it?
Because we're taught by the best teacher in math.
Wow.
Math
All right, guys. Well, I got to go off to lunch. We got pretty far, so we should be able to knock out the rest on Wednesday. All right. Yes. Yes. It's probably just water, to be honest.
Yeah.